In the last video, we wired a passive circuit with a Microbit board as the power source after it was plugged into a USB. And the circuit just used the onboard power from the Microbit to light up a LED light when this little button was pressed. And hey, let's look at that again, because good times. So I'm going to power my Microbit by plugging in a USB cable to it that's connected to my computer. And I'll look at it, and yep, there's the power light. It's on. And that should mean that using this little breakout board that takes the edge connector and provides pins that I have plugged into the breadboard, I have wired one side of this LED circuit to the ground, which is like the negative side of the battery, and the other side I've connected to 3 volts. And now when I push my button, my light turns on. So personally, I think that's pretty awesome. I'm always very satisfied by pushing a button and having a light turn on. But what I think is much more interesting and really extra cool is that I can program the Microbit and have the Microbit decide when the light's going to turn on or off, and do it automatically, and control all sorts of other things. So what I'm going to do now is, instead of getting my power from the 3 volt pin on the Microbit, I'm going to unplug this resistor here. That's the end part of the circuit. And I'm going to plug it into one of the input-output pins on the Microbit. So I think I will just go for one over from the 3 volts is pin 0. If you look carefully at the breakout board here, the pins for the Microbit are labeled. And I have this plugged in. So now it's connected to pin 0. Notice when I hit the button, it won't turn on and off anymore. I'm going to pull the button out of the circuit, and I'm going to put the end of this resistor and the end of the LED on the same row, so that I don't need to be holding the button down for this to work once I've programmed it. So I'm going to take that and I'm going to plug it in right there. So now what I need to do is I need to program the Microbit so that I control that LED using the Microbit. And to do that, I want to introduce you to the digital write command in the Microbit. So now let's go to makecode.com and program the Microbit to control an output, because that's what we have to do to make a robot work. All right. Okay, so here we are at the MakeCode website. You can get here, just type into Google makecode.com, and you'll come here, and then you'll click on the picture of the Microbit. And we're going to click on New Project. So it's going to make us give our project a name, and I'm going to give it a name LED output, because we're going to use a digital output to control an LED in this project. And remember, when a project first starts, commands that we want to have executed just once when it first starts are executed on the onStart block, and then commands that we want to have executed over and over again happen in the forever loop. And if we want to have something happen when we push a button, such as button A, we can have that happen in an on button pressed. So how about in our program, sort of like in our first program, let's put a happy face on the screen just to get the program started. And let's use a pause statement to keep our happy face on the screen for 1 second. And then let's clear the screen when we're done. And there's a clear screen command to make the screen go blank when we're done. And under forever, I'm going to use a new command now to light up my LED. I plug my LED into pin 0, and under advanced, there's these commands called pins. There's lots of different commands here, but we're going to use the digital write pin. So there's a digital write pin statement. Notice it has a little drop-down triangle like the on button command did, and these are all different pins that we could use. The default is pin P0 though, and that's the one we want. If we set P0 to 1, that takes digital pin P0 and it sets it to 3 volts, which will turn our LED on because the other side of that LED circuit is connected to ground or 0 volts. So if we were to run this program right now, all it would do is it would show a face, wait a second, clear the screen, turn the light on, and that's it. But let's add a little bit to this. Let's duplicate that pause statement, and I'm going to duplicate this statement by right-clicking to get another digital write. I could have also gotten that by just dragging it from over here like I did the first time, but when I can, I like to just duplicate. I think it's faster. So now I have a program that turns on P0, waits a second, and then essentially it turns on P0 again because this is a 1. So I want to change that, make it a 0, and now it turns on pin 0, which will turn on the light. It turns off pin 0, or sets it to 0 volts, which turns off the light, and after each of those it waits for a second and just does this forever. So I'm going to load this program, and we should see an LED on pin 0 blinking on and off, on for 1 second, off for 1 second. So let's download. I'm going to show in folder, so I'm going to right-click down here. And then I'm going to drag my program and drop it on the device called Microbit. And right now it is loading on. Remember, you can see the light blinking while the program's loading. And now that it has loaded, there's my happy face. And you can see that the light's turning on and off, on for a second, off for a second. So there we go. Yay! We did it. We controlled an output with the Microbit. And that's important because for us to make a robot work, we're going to have to control two outputs per motor to give the motor controller the signals that it needs to direct the wheels on the robot to turn those motors on and off. And that's what we're gearing up to do next. But I'm going to explain motor controllers to you a little bit first, and I need to show you how to hook up the motor controller. So we'll be doing that, and I'll see you in the next video.